When we have a right triangle, we can use Pythagorean Theorem. We can use SOHCAHTOA. When we have a non-right triangle, what are we left with?
Sine.
Law of sines. Okay? Now, just to make sure we're all on the same page, this SOHCAHTOA thing, I'm going to do a little acrostic. Okay, this means sine is opposite over hypotenuse. Get it? S-O-H, S sine, O opposite, H hypotenuse. Cosine is adjacent over hypotenuse. Get it? C cosine A adjacent H hypotenuse. Just making sure everyone's on the same page. Tangent is opposite over adjacent. And just as a reminder, sine is abbreviated like that. It is still pronounced sine. It is not sin. Cosine is abbreviated like that. It's still pronounced cosine, not cos. Tangent. Sometimes people do call it tan. Don't ask me why tangent has separate rules. I like to say sine, cosine, tangent. Okay? Just don't say sin and cos. That just really, you know.
Sin?
Yeah, you deal with that in church, not in math class. Okay. So, do I have a right triangle?
No.
No, which means that I'm going to have to use the law of sines at some point. However, I know two of the three angles, right? So how can I find the third angle?
Subtract.
180 minus 34 minus 38 gives me 108 degrees. Did I mark you off if you did not put the degrees symbol? Yes.
Oh.
Why did you make that?
Biscuit.
By the way, this is mostly going to be on the computer. Your answer sheet, you'll have your usual answer sheet. The only thing that you're actually going to have to do on paper is these three guys. Or these four guys. I can count. Okay? So there will be four of these guys on there. You will input the reference angle on there on the computer also. I will not be labeling things. So if it is kilometers, I'm expecting you to type in km.
Oh, it's on the computer?
Yes. If it's degrees, I'm expecting you to find the little degree symbol, which on the computer it's on that second tab. I think we've done that before, yeah? I'm expecting you to put the symbols. The reason why I don't want to put the symbols there for you is because I noticed many people are confused about when it's an angle and when it's not an angle. So I'm hoping that we can alleviate some of that. Okay? So, in this triangle, what side, let's see, I still need little b and little c. What side is little b?
AC.
It's that one, right? Because that's what's across from there. And this one is what? Little c. All right. So let's say I wanted to find side B. I'm going to do sine of 34 degrees over B, right? Angle on the side opposite is equal to, I need another one with the angle on the side opposite. Well, I can't use 38 and C, but I know that this is 108, right? So I can do sine 108 degrees over what?
17.
17. So when I cross multiply, I get 17 sine 34 degrees is equal to B sine 108 degrees. I'm going to divide by sine 108 degrees. And that's going to leave me with B equals whatever I get for the answer here. Let me make sure I'm in degrees. Yes. 17 sine 34 gives me that. Divided by sine 108. 9.99. What does it say as far as rounding? Nearest tenth. So 9.99. The nearest tenth is actually 10. So what am I going to label it as? 10. Did I take off if you didn't put kilometers?
Yes.
Yes.
How many points do you take off?
Depends on if I'm feeling good or not.
So what if you miss?
I think I took off a half a point every time you did it.
What if you miss like a degree?
The degree symbol, you lost a half a point. I know. Life's rough. Okay, so that's 10. So now I'm going to do this same setup as far as the sine 108 over 17. But my other fraction this time, I need to find side B. So what am I going to put? Did I say side B or side B? I need to find side C.
So
Sine 38 degrees over C.
sine 34 over C.
Sine 38.
Oh,
Okay.
so
Now again, it doesn't matter which fraction you write first because you're going to cross multiply. So I have C sine 108 degrees equals 17 sine 38 degrees. Divide by sine 108 degrees. Why can't I use Pythagorean Theorem if I know two sides, by the way?
Because there's no right angle.
It's not a right triangle. 17 sine 38 divided by sine 108, 11.00. That rounds off to 11 what?
Kilometers.
So if you didn't put degrees or kilometers, you missed a point and a half on that. Half a point, half a point, half a point. Make sure you're labeling.
is that on your left?
Okay? Questions there? Fantastic. Number 2. Yay for number 2. It's a right triangle. That means I can use Pythagorean Theorem. That means I can use SOHCAHTOA.
Yes.
I'm going to use Pythagorean Theorem first just because there's only one side that I need to find. So let's see. I'm going to call it little b because that's what it's called over here, right? So I'm going to say 7.1 squared plus b squared equals 12 squared. Yeah? So let's see, what's 7.1 squared? 7.1 squared is 50.41. And 12 squared is 144. I'm going to subtract 50.41. So b squared equals 144 minus 50.41, 93.59. So if I square root that, I'm going to do second square root, second answer. 9.67 rounds to what?
7
9.7. So I'm going to call this 9.7 what? Miles. Now, if I can avoid it, which I can, do not use that 9.7 to calculate either measure of angle A or measure of angle B. Why?
Because it's not exact. It's rounded.
That is one reason. The other reason is, what if I got it wrong?
Yeah, that's it.
If I got it wrong, I'm making sure that I'm going to get the other ones wrong too. So go back to what's given so that way you have a chance of getting it right at least. Right? So if I wanted to find angle B, for example, and I wanted to use this one and this one, the two givens, how are these related? I have the hypotenuse and I have what?
Adjacent.
What uses hypotenuse and adjacent?
Cosine.
Cosine. So I'm going to say the cosine of angle B is equal to adjacent over hypotenuse. How do I find angle B then?
Good question.
Inverse cosine of 7.1 over 12 will give me B.
Wait, Miss Rankin?
Yes?
Can you still do the law of sines on right angle triangle?
It's a pain. I don't know. It's tricky because what's the sine of 90 degrees?
1. Right?
Yeah. I think you can, but I don't know. I don't know off the top of my head if your calculator is going to freak out or not.
Okay.
Okay? So this is the safer route to go. Let's see. So I get angle B is equal to 53 point what?
7.
72 rounds off to 7 degrees.
Oh yeah, I got it.
So angle B is 53.7 degrees. And now I don't need to do trig again because I can do 180 minus 90 minus 53.7 and I get 36.3 degrees.
Yeah, I use the one side. I still got the right answer.
Okay, good.
When do you use the inverse? Just when you're finding the angle?
When you're trying to find the degrees of the angle, yes. Okay, that's when you use the inverse. Any other questions? Those two were kind of hefty, 5 points each. Okay. All right. Find the exact value of the trig function indicated. It scared the snot out of me when I saw a group that put degree symbols after all of their answers. The sine of an angle is not a degree. The cosine of an angle is not a degree. Isn't the sine of an angle a y value?
Yes.
It's not a degree measure. Completely different things. So if I'm asking for the tangent, cosine, sine, tangent, I'm not asking for a degree measure. So this one's nice. By the way, it was not clarified here. It will be on the test, but assume these four are all right triangles.
Okay.
Right triangles. Okay. You can use SOHCAHTOA on these. The other thing is that I'm noticing that we have radicals, and there's nothing in the instructions that says round. That means what?
You have to put it as right.
Exact answers, not decimals. Okay, so we need to leave them as radicals. So, what do I know about tangent? It is what?
Opposite adjacent.
Opposite over adjacent. So here's theta. I need opposite over adjacent. What is opposite theta?
2, 6.
2. What is adjacent theta? What does that reduce to? That was the easiest 3 points of the test. Should have been. Yes, I do take off a point if you put 2 6 and don't reduce it. Okay? All right. The next 3 are a little different because why?
They have.
There's no picture. So I'm going to draw a picture. What? There's my picture. It's lovely, isn't it? When we draw a picture of a right triangle, what letter do we always call the right angle? C.
Wait, why?
It's just always right angle C. It's just standard. I'm going to call the top A and the bottom B. Doesn't matter which one you call A and which one you call B. It only matters which one you call C because it's the only way you get the hypotenuse being little c, right? And then this would be little a and this would be little b. So the cosine of A would be adjacent over hypotenuse, right? What's adjacent A? It's little b. And the hypotenuse is little c. Yeah?
Yeah.
So I don't know little b, but I do know little c is 3 rad 13. So I know I'm going to end up having to rationalize that denominator. How do I find little b? Let's see. This is 3 rad 13. This is 6. Pythagorean Theorem. 6 squared plus b squared is equal to 3 rad 13 squared. So let's see. 36 plus b squared is equal to, this has to be 3 squared, which is 9. And what's rad 13 squared?
13.
Okay, what's 9 times 13?
107.
107, you said?
117.
117. So what does b squared equal? 117 minus 36? 81. So what does b equal?
9.
So many groups did not get that. So I put a 9 right here because that's what b is. Yeah? How does this simplify? Well, I got to multiply by rad 13 over rad 13. But even before I do that, I could simplify this, couldn't I? Call that a 3 and a 1. So that's 3 over rad 13. What am I going to do to rationalize that?
Multiply the numerator and denominator by rad 13.
Yep, rad 13 over rad 13. That gives me 3 rad 13 on the top, and what on the bottom? 13. Can that simplify it all? So my answer is 3 rad 13 over 13. A lot of groups didn't get that. A lot of groups got 2 rad 13 over 13, and I think it's because they put the 6 over that. They did the sine ratio instead of the cosine ratio. So? All right, number 5. Find the sine of theta if the tangent of theta is equal to 12 over 5. Okay, well, let's see. Again, I said assume we have a right triangle. Theta you can call any angle except the right angle. Doesn't matter which one. So I'm going to call theta up here. Tangent is opposite over what? Adjacent. So opposite is 12, adjacent is 5. If I need sine, I need opposite over hypotenuse, right? Well, I know opposite is 12, I don't know hypotenuse. How do I find hypotenuse? Pythagorean Theorem again. 25 plus 144 equals c squared. What's 25 plus 144? 169 is equal to c squared. So what does c equal? 13. This is one of those, we call it a Pythagorean triple. 5, 12, 13 makes a right triangle. 3, 4, 5 is another Pythagorean triple. 3, 4, 5 can be the sides of a triangle. So let's see, my hypotenuse is 13. 12 over 13 can't reduce. So that's my sine value. Number 6 is kind of the backwards of number 5. Number 5 said find sine if I give you tangent. Number 6 says find tangent if I give you sine. Okay, so let's see. If I draw my right triangle again, I'm going to call the top one theta. I always like to use the same angle just so I remember opposite and adjacent. Sine is what? Opposite over hypotenuse. So here's opposite, here's hypotenuse. Tangent, I need opposite over adjacent. I know opposite is 1. Adjacent, I don't know. How do I find adjacent? Pythagorean Theorem. 1 squared plus b squared equals 4 squared. So 1 plus b squared equals 16. So what do I get? B squared equals 15. B equals radical 15. Can I draw a tree for 15?
No.
Well, I can draw a tree, but it doesn't do me any good because there's no pairs to come out, right? So I just have 1 over rad 15. How do I get rid of that radical on the bottom?
Multiply rad 13.
Rad 15 over rad 15. I get rad 15 on the top, 15 on the bottom. That's my answer. Rad 15 over 15. Any questions on those 4?
Wait, how do you get it off the bottom again? The radical off the bottom.
Same as I did up here. I multiply by rad 15 over rad 15. 1 times rad 15 is rad 15. Rad 15 times rad 15 is actually just 15. Okay? So? Okay. So, on your individual test, I'm going to give you this same information. Now, this particular group chose to go write some stuff in. That's fine. I am not going to grade anything you write on this, so you are not required to fill this out at all. It's just a reference for you. Okay, so this will be provided on your answer sheet. The first quadrant will be filled in. So, when it says name 2 angles in degrees that both have a tangent undefined. Remember, tangent is sine over cosine. How does tangent become undefined? When cosine is 0. In other words, when an x value is 0.
Oh, it's like an impossible.
When do I have an x value of 0?
90 degrees.
90 degrees and
270.
270. So those would be my 2 that have a tangent undefined. 90 degrees and 270 degrees. Most people did okay on that one. The next one, name 2 angles in radians. Some people gave me degrees. I don't give you any credit for not reading directions. that both have a sine value of negative radical 3 over 2. What is sine again?
Y.
Sine is y. So first off, we're talking about a negative y value. What quadrants have a negative y value?
By left.
These two quadrants, right? 3 and 4 have negative y values, correct? So now I just need to know, is it these two angles? Or is it these two angles that have a y value of negative rad 3 over 2? Well, negative rad 3 over 2 is the longer leg of the 30, 60, 90 triangle. So it's going to be these guys because that's the longer leg. That's the shorter leg.
Right.
Longer leg, shorter leg. So I need to know what these two angles are in radians. Well, if they are 60-degree reference angles, I have 1 pi over 3, 2 pi over 3, 3 pi over 3. This is going to be 4 pi over 3 and 5 pi over 3 because this is 6 pi over 3. So what are my answers? 4 pi over 3 and 5 pi over 3. Now, if you take a minute to fill this out beforehand, you don't need to calculate that. You just need to look and see what's written there, right? Okay, questions there?
Wait, so how did you find that? Like, how would you know that you're looking for those two spots on the unit circle?
Because any other two angles that have the rad 3 over 2 as the y value have a positive rad 3 over 2. Here and here. This one specifically said negative, which automatically directs me to this quadrant, or those two quadrants. Okay?
And you found the angles. Which angles between the two angles? How? Because you had like two angles in each quadrant.
Just from our unit circle quiz, you would know that this is pi over 3, this is 2 pi over 3, this would be 3 pi over 3, this is 4 pi over 3, and this is 5 pi over 3. And this is 6 pi over 3.
Yeah.
If you were to just basically fill out the unit circle, you would have it labeled there.
Yeah. Like, how did you figure out? Because like there were like between the two from 11 pi over 6 and 7 pi over 6. How did you figure out this between? Yeah.
Oh, because how did I know it was this one instead of this one?
Yeah.
Because I know that root 3 over 2 is the longer leg. So if the longer leg is the y value, it's going to have to be this triangle because in this triangle, the longer leg is the x value.
Okay.
So
Do you
the
see
sine
that?
is the y value?
Huh?
Sine is always the y
Sine
value.
is always the y value.
Okay, so that means cosine is the x value.
Cosine is the x value.
Okay, so we
Oh,
Yep.
okay. So because y value is 30.
Mm-hmm. Okay. All right, backside. Here we go. These are the ones you're going to have to do on paper. However, you will type the reference angle in on the computer. Now, I will say this. There's just going to be 4 of these, so you are going to need to write the degree that you're given, either 480 or pi over whatever, because I need to be able to look at that when I'm grading it to make sure that it matches up. What do I know about 480 degrees? I know it's positive, which means I'm going to start off by going up. I also know that it is degrees. I'm going to be counting in degrees. Also, it's more than 160. Sorry, 360. It's more than 360. So I know that I'm going to go past that. Right? That's 360. What is my next quadrant? If I were to go up to 90 degrees, 360.
450.
360 plus 90 means up here we're at 450. I can go ahead and draw that in because 450 is not yet to 480, is it? Okay. 450, the next 90 degrees would be 540, and that's too far, isn't it? So if this is 450, 480 is going to be a little bit past there, correct? So I can go ahead and draw that. And if this was 450 and this is 480, what is this angle right here? 30 degrees, right? 450 to 480 is 30 degrees. So what is my reference angle here? 60 degrees. Now, I did take off points if you do not label your reference angle on here. Now, you can label your reference angle, or you could label the 30-degree angle there. But you already had to calculate your reference angle, so why not just label your reference angle, right?
Is reference angle always to the x?
Always to the x-axis, always positive. Always acute.
Okay. All right. For sure.
Okay? Because if you think about it, if you're always going to the x-axis, think about this. You go up and up and up and up, here's 60 degrees. As soon as you get to here, and you pass that 90-degree mark to make an obtuse angle, your reference angle isn't on this side anymore, it's on this side.
Oh, okay.
So it can never be more than 90 degrees. Okay?
So it's never y?
Huh?
Like, it's never in the y?
It's never goes to the y-axis, no. Always x-axis, acute, positive. Those are its 3 rules. Okay? Reference angle here for negative 510 degrees. It is negative. What does that tell me? It's starting off going this way. 510 is more than 360, so I know I'm at least going there. From the last problem, I know that an additional 90 degrees takes me to 450, correct? What does an additional 90 degrees take me to? 540. I don't need to go quite to 540, do I? I need to go a little bit less than that. So I'm going to draw my terminal side and finish off my angle. Please put an arrow there. Please put an arrow there. Don't be lazy. Yes?
So, you know how you were saying that if you go like past the y-axis, it's on the other side, it's no longer like
Uh-huh.
Q. So could it be 90? Like it couldn't be exactly 90?
It could be exactly 90, yes. But it couldn't be more than 90. Okay, so let's see. I went my 360, 450. This is 510. What was the next line going to be? 540, right? So if I'm at 510 and this is 540, what's that difference? And that's my reference angle. Capiche?
Yeah, ma'am.
All right, now we get to radians.
Yikes.
Some people prefer to do radians by transferring them to degrees. However, if you label your reference angle here or here in degrees, they take off a point. If I'm speaking radians to you, you need to speak radians back to me. Speak my language. Okay? All right, negative 7 pi over 6. I know that that is going to go down. Yes? So I just got a little mark there to start to remind myself that I'm starting going down. 7 pi over 6. Is that more or less than 1 pi? More than 1 pi, right? Because what would 1 pi be?
180.
Or
0.
6 pi over 6?
Oh, yeah, 6 pi over 6.
Do you get that? What is, well, let's see. You just told me that 1 pi is 180, so I know it's going to be more than that.
Right.
Yeah? And if 180 is 6/6, and I need to go to 7/6, I'm just going 1/6 further, aren't I?
Yes.
So that's where my terminal side is. And I just went 1/6, which is pi over 6. And remember our shortcut? That for these unit circle angles, if you have a denominator of 3, 6, or 4, your reference angle is pi over 3, pi over 6, or pi over 4.
Wait, say that again?
For our unit circle angles, I wrote 3 and I meant 6. Nobody corrected me there.
That's why I was.
For our unit circle angles, if you have something over 6, your reference angle is pi over 6. If you have something over 3, right here, your reference angle is going to be pi over 3. If you have something over 4, your reference angle is going to be pi over 4. That only works for our reference or for our unit circle angles, though. When you get into pre-calc next year, it's not always going to be the case. Okay? If your denominator is like a 12 or something like that, or an 18, you can't always assume it's going to be pi over 6, pi over 3, pi over 18. It might be something different. Okay? All right, 11/3 pi, or 11 pi over 3. Okay? This is a positive one, so I'm going to put a little bit of a mark there going up, so I remind myself what direction I'm going. This time we're talking about thirds, right? So wouldn't this be 3/3?
Uh-huh.
So another one would be 6/3.
Right.
Yes?
9.
9 would be another 180. I don't want to go to 12. I'm going to stop 1/3 before there, aren't I? So 1/3 before there would be pi over 3, and I'm stopping right there. Yeah? Quick reminder from your unit circle, how many degrees is pi over 3? Nope. 60. How many degrees is pi over 6? 30. How many degrees is pi over 4?
45.
45.
Yeah, man.
Okay. All right. 413 to 15, find the exact value of the reference, find the reference angle and the exact value of the trig function. This one I am speaking radians. I expect your answer to be radians. Now the sine value is not an angle measure, so it's not radians. Just the reference angle would be. What do you notice about the angle that's given to you?
Pi over 4.
It's over 4, so my reference angle is
45.
Pi over 4.
pi over 4. Do not write 45 degrees. We are speaking radians here.
You're right, sorry.
Okay. What quadrant is my terminal side in? Fourth quadrant.
Yeah.
Is sine positive or negative in the fourth quadrant?
Negative.
All students talk crap.
Yeah.
So cosine's the only thing that's positive, so sine is going to be negative.
Oh, that's all you write.
No.
Oh, no, wait. No,
Give me
I
a
didn't-
minute to
I
finish.
didn't finish.
And once I've identified the positive negative thing, I don't care anymore about the quadrant. I just care what's the sine of pi over 4. Well, if I go to what's given, pi over 4, sine is root 2 over 2. So what's the sine of 15 pi over 4? Negative root 2 over 2.
Wait, you just put y. Right. Because it's sine.
Yep.
It's fine.
Okay, since I'm in radian mode, I'm going to do number 15, and then I'll go back to number 14. Negative 7 pi over 3, what's my reference angle? Pi over 3. I'm asking for the cosine, and if I remember, all students talk crap. What is cosine in the fourth quadrant? Positive. It's the only thing that's positive in the fourth quadrant. So, I just need to know that it's positive. I need the x value of pi over 3. Pi over 3, x value is 1/2. Cosine of negative 7 pi over 3 is positive 1/2.
I'm so confused.
Tangent is both, right?
Oh, wait a minute.
Okay? So what are you doing? You are simply looking up the sine, cosine, or tangent of the reference angle to get your answer. But then based on what quadrant the terminal side is in, tells you whether to throw a negative sign on that number or not. Okay? Don't overthink it. It's not as complicated as it seems. Tangent is a little different. Tangent is sine, or y, over cosine, which is x. I personally like to memorize it from that chart in our notes, and I know that the tangent of 30 degrees is root 3 over 3, and the tangent of 60 degrees is root 3. How do I know that? Well, let me show you. I'll go back just to remind you here. That's all from this chart right here. Remember this? I know how to find sine and cosine. That's easy. Tangent is either 0 or undefined, but that's only for 0 and 90 degrees. It's 1 if it's 45, so I just memorized that 30 degrees is the more ugly one, the root 3 over 3. 60 degrees is root 3. If you don't memorize that, you can always do sine over cosine and then do the work to actually simplify. So, I just need to find what's my reference angle. So let's see. How many revolutions do we have? Let me see if I can use some different colors to help out here. So let's see. This right here, this first revolution, hard to see, but that's 360, right? And then this would be 720. So let's see. This is 720 plus 90. 720 plus 90 is 810. If this is 870 all the way to here, this label is labeling the entire thing. 870, if I subtract that, that means this is 60 degrees, right? But that's not the reference angle, right? 30 degrees would be the reference angle. So 30 degrees. Tangent of 30 degrees is root 3 over 3. Is tangent positive or negative in the second quadrant?
Negative.
Negative. So my answer has to be negative root 3 over 3. Okay. Questions there? All right. Last problemo. Use the given point on the terminal side of angle theta to find the exact values of the trig functions. Well, this is the one where I have to make a triangle. Make a right triangle specifically. So if I draw that triangle larger out here, do you see how this is exactly the same triangle, just blown up so I can actually see what I'm looking at? Okay. I'm going to label my sides. My x value is 5. My y value is 12. Notice I didn't put negative 5 because now I'm going to look and see that's a second quadrant angle. What is positive in the second quadrant? Only sine. So cosine and tangent are both negative. Which angle do I label theta? Never your 90-degree angle. Which one of the other two is at the origin?
Oh, wait.
Has to be the origin angle. So this one right here is the one we're calling theta, because our angle is always measured around the origin when we're talking about standard form. How do I find that other side? Pythagorean Theorem. 5 squared plus 12 squared.
13.
12 squared equals c squared. So 25 plus 144 equals c squared. 169 equals c squared. C equals 13. Yes, I did that fast. Because again, that's a Pythagorean triple. 5, 12, 13. All right, so sine. Opposite over hypotenuse. 12 over 13. Cosine. Adjacent over hypotenuse. 5 over 13. Tangent. Opposite over adjacent. 12 over 5. By the way, if those numbers were able to be reduced, you must reduce them. But once you have all three sides, it should take you 2 seconds to fill in those three values. Okay? Again, are those degree values? No, they're trig ratios. They're not angle measures. Yes?
If we put the negative, because I know the whole number is negative for the cosine and tangent, but if we put like the negative sign on like one of the numbers instead of, like on the 5 instead of
It's fine, as long as it's only in one place. When you type it into the computer, it's easier if you just put it out front on the fraction.
The reason we don't put 12 over 13 is negative, but we put sine and use the ASTC.
Yep, because all students talk crap means sine is positive in the second quadrant. Okay? Any other questions? Happy studying.